In this internal assessment video, I will go over the analysis section of the IA, common descriptive and inferential statistics that are applied, and how to generate the same using Excel. The analysis section of your report aims to test for your hypotheses and to get an understanding of what your data is suggesting. And for the same reason, this section can only be completed after you have conducted your experiment and have your data in place. It is important to ensure that you have applied the appropriate tests and measures, as it not only influences this section, but also how you evaluate your research in the next section. So to begin with, the high range descriptors, this section is out of 6 marks. So the high range descriptors are: descriptive and inferential statistics are appropriately and accurately applied. The graph is correctly presented and addresses the hypotheses. The statistical findings are interpreted with regards to the data and linked to the hypotheses. So keeping these descriptors in mind, this section requires the following off from your report. First, descriptive statistics including a measure of central tendency, measure of dispersion, one table, and one graph is required. So students often get excited and add multiple graphs which are unrelated to the hypotheses. It is important to ensure you use a graph that is appropriately representative of your data and is in relation to your hypotheses. For example, if you are testing depression scores before and after an intervention, let's say CBT, the graph would present mean scores in the pre-test and in the post-test. Okay, so these are the two conditions: pre-test and post-test scores of depression. So you would use mean and a bar graph along with its error bars if there aren't too many outliers in your experiment or in your data. So, an appropriate statistical test enables you to accept or reject your hypotheses, and this needs to be applied as well. I will discuss this in detail later in this video. Along with your calculations, you need to explain why you chose those measures and the test that you chose, and what your data is indicating in relation to your hypotheses. So it isn't enough or sufficient to include just the calculations without having to explain them or discuss them. Okay, and finally, not to forget raw data and inferential calculations that need to be added in your appendices and submitted to your examiner along with your report. So for the inferential statistics, it could be a screenshot of the product on Excel, SPSS, or any online calculator. When they mean calculations, it doesn't mean that you have to show step by step. Just a screenshot from whichever calculator you've used is good enough. Okay. So if you do not include your raw data in your appendices and your calculations in your appendices, it can just result in unnecessary loss of points. For not including your raw data, you would get a max of 2 out of 6 in this section, regardless of if everything else is in place. Not having your raw data would result in that. So it's just the matter of including it in your appendices. And if your inferential statistics calculations are not in your appendices, you would get a 3 out of 6 in this section. So moving on, descriptive statistics is what we will discuss next. Descriptive statistics are a group of measures that are used to describe the basic features of the data. One could consider them summaries of what the data shows. Using descriptive statistics, one cannot accept or reject a hypothesis. And for the same reason, if you just apply descriptive statistics, you won't be able to evaluate and also even relate your current research to the original research and theory or model. Okay, so it is important to include both descriptive and inferential statistics. As mentioned earlier, you need to include a measure of central tendency, measure of dispersion, a table, and a graph. This means that you do not need to include all descriptive statistics, just one which is most appropriate. So one measure of central tendency, one measure of dispersion, that would be sufficient for you to use in this section. Okay. So the mean is the most common measure of central tendency. It is simply an average of the data. The mean is calculated when the data doesn't have a lot of outliers and is normally distributed. Whereas the median is calculated when a data set has multiple outliers that may affect the calculations of mean. So if we look at what outliers are, if you're looking at Loftus and Parma's research, okay, and they are asked to estimate the speed at which the cars were traveling. So an outlier could be 120 kilometers per hour, okay? If you see that the rest of the group has estimates around 60, okay, and 120 is definitely then an outlier. So if there are multiple such outliers, then you would use median because that outlier can affect mean, okay? So standard deviation is a measure of variance used with mean as it represents the plus and minus variation from the mean. Okay, so when you're using mean, you would use standard deviation as the measure of dispersion. And for the same mean and standard deviation, you can use a bar graph along with error bars to represent the mean and standard deviation. So with median, interquartile range is the most relevant measure of dispersion. It um, represents the plus and minus from the median, okay? And quartile 2 is the median. So quartile 1 is the lower range or the negative variance, and quartile 3 is the positive variance, okay? So finally, there's mode, which is the value with the highest frequency. So for example, if a class of 10 students were asked where they'd like to eat um, lunch for a treat that the teacher is giving, and 7 said Subway, 2 said McDonald's, and 1 said KFC, the mode would be 7 for Subway. Okay, mode can be used with nominal data, and the measure of dispersion would be variation ratio. So in the next few minutes, I will go over how to calculate mean and standard deviation and how to represent that on a chart or how to plot that on a graph using Excel. I'm focusing on mean and standard deviation because those are the most common ones. Plotting median and interquartile range and also mode and variation ratio are pretty simple. For median and interquartile range, you can very easily use a box and whisker graph. So for the purpose of calculations, I will be using the same depression pre-test, post-test example. Let's assume that the sample includes participants who have severe symptoms of depression with a score of 70 plus during pre-test. We want to see the average or mean during pre-test and also following the intervention. Has the score reduced, increased, or remained the same? So in order to calculate the mean and standard deviation, I'm going to start by creating a simple table. And following that, I'm going to go to under the pretest and mean, and I'm going to click equal to and find average, and then select all the scores that fall under the pretest table. Okay, so all 15 scores. And then I'm going to click enter. And then I will do the same, equal sign average, and select all the post-test scores and include all the samples from that and click enter. The standard deviation can be calculated just as seamlessly as we calculated the mean. You will click on equal to and type ST. Under that, you will find standard deviation P and standard deviation S. You will choose the S because that is for sample, which means you have only chosen a few people from that population. Standard deviation P would include everyone in the population. So once you've clicked on standard deviation S, you will choose the same data from pretest and you will click enter, and then you will follow the same procedure and click standard deviation S, choose your whole data for post-test and click enter. So this is how seamlessly you can do standard deviation and also mean. So the graph most appropriate for mean and standard deviation would be a bar graph along with its error bars, and that is what we're going to look at next. So in order to create a bar graph, you have to select your mean along with the two conditions and go to insert, okay? And under insert, you can go to the column graph and choose that pretty easily, okay? Now, naming your graph is very important because that can help you make it more explicit about what it is referring to in regards to the hypotheses. So in this case, I'm going to look at major depression scores before and after intervention, okay? So make sure that you name your graph. So what we're going to do next is add error bars to our chart, which is basically the standard deviation, okay? In order to do so, you go to chart design, and under chart design, you will find the option of add chart element. And this is on MacBook, but the same can be found under layout for Excel for Windows, okay? So under add chart element, you will find error bars, and there's an option for standard deviation, but do not select that. Choose more bars, more error bars option, okay? Once you have the format error bars chart open, you have to click both because you want to see both plus and minus. And then instead of the fixed value of standard deviation, you will choose custom values and click on specify value. Once you have have that window open, you click on the positive values, which is the same as the negative values of standard deviation. This is from the calculation that you did before, and you just click OK. And with that, you have your error bars quite seamlessly added to your chart. And in order to export this or use this in your report, you can just click copy and paste. So moving on to inferential statistics. As the name suggests, inferential statistics are a group of statistics that allow us to infer and come to conclusions based on the data that we have collected. It is with inferential statistics that you are able to accept or reject your hypotheses, which isn't possible, as I've mentioned before, with descriptive statistics. There are several different types of inferential statistics, and they can be categorized into two main groups: parametric and non-parametric. Parametric tests are used when your data is normally distributed, which is when all the values of a given variable cluster around the peak, as seen in the bell curve on the right side of the screen. And this gradually reduces as the data or values go further away from the mean. The peak is basically the mean. So a non-parametric test are those used when the data you have collected are not normally distributed. As we are hypotheses testing, we also need to be recalled of one-tailed and two-tailed hypotheses. A one-tailed hypothesis is directional, and you are hypothesizing that scores in one condition will be better than scores in the other condition. Okay? And two-tailed hypotheses consider both possibilities, hence hypothesizing that there will be a difference or a statistically significant difference between the two conditions. It just doesn't say which will be better than the other. It will just say that there is a difference between the two conditions. Okay. So when it comes to hypotheses testing, all statistical tests, including the normality tests such as Shapiro-Wilk, which is a type of normality test, they assume the null hypotheses. So that means they're testing the null hypotheses and not the research hypotheses. I guess the purpose of this is standardization, and it is easier to test for a null hypothesis that says that there is no effect or that there is no difference than to test for all the different types of research hypotheses that there are. Okay. Um, the 0.05 alpha error is something that a lot of people continue to remain confused with, and it is pretty simple. Okay. So accepting and rejecting a hypothesis is dependent on the p-value. So every statistical analysis that you do will provide you a p-value at the end of the analysis, okay, which is the significance value. And this significance value needs to be compared to 0.05, which is the alpha error value. The alpha error value can be adjusted to 0.1, 0.01. It really depends, but 0.05 is usually the one that most researchers use, okay? And this Alpha error value is basically the percentage of error or chance that we are allowing in our research. And when I say chance, I mean that the two variables that we have, the relationship between the two variables, how much of it is dependent on chance, okay? Or how much of the hypotheses are we allowing to be dependent on chance or just a fluke relationship, okay? So there could be extraneous variables and error that could be involved, and how much of that are we allowing. So with a 0.05 out of 1, which is 5%, okay, of alpha error that we are allowing, okay, this also then means that we are aiming to have a 95% confidence in our hypotheses and the data to confirm that, okay? So 95% confidence, saying that I am 95% confident that this hypothesis is valid. The rule of accepting and rejecting the null hypotheses is as follows. Again, you use the alpha error value of 0.05. If the p-value that you get from the test that you have conducted is greater than 0.05, let's say it is 0.07 or 0.2, then we accept the null hypothesis. That says that there is no difference, okay? If the p-value generated by the test is less than or lower than 0.05, maybe it's 0.02 or 0.01, then we reject the null hypotheses, okay? When we reject the null hypotheses, we are then able to accept our alternative research hypotheses, okay? And that alternative research hypothesis is going to say that there is a significant difference, or condition 1 did better than condition 2. Okay, so once you have collected your data, this is the steps that you can follow to analyze it. Okay, first you tabulate your data into the two conditions. All the values in condition 1 and all the values in condition 2 need to be entered into Excel. Then you can use and okay, so here's a confession and like an honest review. At the beginning of this video, I said that I would be using Excel to do all of the analysis and show you how to do that. But as I progressed through this video, I found that Excel with inferential statistics, it expects you to do multiple steps, and it's really not necessary for you to do that. So if you can get your hands on SPSS, IBM SPSS, that is great, because I think that is the best software for statistics. But there are also a lot of online calculators that are accepted by the IB and also are pretty reliable calculators. So I would recommend that you use that instead of having to do all the steps required on Excel. Okay, and that is what I will show you in the rest of this video. So after you have tabulated your data, you can determine you have to determine whether your data is normally distributed or not, because that will help you decide your descriptive statistics and your inferential statistics as well. So once you have found out your normal distribution, you can go ahead and use Excel for your descriptive statistics, including the graph. And then after that, you need to decide which inferential statistic test you need to choose for your data and which is the most appropriate. So once you have conducted all of that, that is when you can interpret and report your results in your IA analysis section. Okay, so what I'm going to show you now is very simple online calculators that can help you determine whether your data is normally distributed or not, and also different inferential statistics that you can choose after you've decided that. So in order to determine whether your scores from your test and data are normally distributed, I would recommend using gigacalculator.com. It is a very easy calculator that you can use online, and it just requires you to enter your data from Excel, copy paste it. Like any other test, as I mentioned before, normality tests also assume the null hypotheses and test for the null hypotheses. And in case of normality testing, the null hypothesis is that the dispersion of your data is no different from a normal distribution. Okay? So the distribution of your data is no different from a normal distribution. So any p-value that is greater than 0.05, or any value that you get from this test is greater than 0.05, it accepts the null hypotheses, which means that your data is normally distributed. If it is lower than 0.05, it rejects that null hypothesis that said there's no difference, and accepts the fact that there is a difference, which then means that if it's lower than 0.05, your values are not normally distributed. Okay, so once you've understood that, I think another thing that you need to understand is there are several different tests of normality. I would recommend Shapiro-Wilk because it is known to be a test of the highest power when it comes to normality testing. Okay, so it is the best test of normality. Um, so what you can do is go to your Excel, okay, and copy paste only values from one condition at a time. Okay, so you click on pretest scores and you paste it here, okay, and you click on calculate. And the Shapiro-Wilk score, which is the first one that will show up, is 0.15, which is greater than 0.05, suggesting then that the data from the pretest scores are normally distributed. Okay, and I would recommend that you take a screenshot of this. You can just do a selection of this area and get the Shapiro-Wilk scores. Okay, so then you can go back and then select the data from the post-test and follow the same procedure. And here, even though not as much as the pretest scores, it's 0.06, the Shapiro-Wilk's p-value, and that is still greater than 0.05. So that again suggests that the post-test scores are also normally distributed. Okay, so now based on the fact that both the conditions, okay, take a screenshot of this as well and include it in your appendices. So now based on the fact that both of the tests are normally distributed, you can now determine which statistical inferential statistics you will use and also descriptive statistics you will use. So for normally distributed data, mean and standard deviation are the best measures of central tendency and dispersion. Okay, and I will go back to looking at a table of common inferential statistics that you can use for your IA. So in this table, I have listed 4 most common inferential statistical tests that you can use for your IA, considering the fact that it is recommended that you choose only 2 conditions, okay? And these conditions can be either in a independent measures design or a repeated measures design, okay? So what the IB recommends or is accepting of is the use of non-parametric tests, because what usually happens is when there is a sample size less than 30 participants, it is unlikely or it is less likely that the data is normally distributed. So they are fine with you going directly for non-parametric tests such as Mann Whitney U test and Wilcoxon's sign rank test. But I usually prefer for a normality test to be conducted, okay, like I showed in the previous slide, so that you are able to choose a more accurate test for your data. And also, that gives you one more reason to explain how you chose the test that you chose, which is one of the requirements for your analysis section. Okay, so those are my recommendations. And if you are going to use a parametric test and your data or your sample is less than 30 participants, you need to ensure that you use your normality test scores in your analysis section and explain that that is why you chose an independent samples t-test or a paired samples t-test. Okay, so the first one, which is the independent samples t-test, is a parametric test. Okay, and you use the mean when it comes to this because it is a normal distribution. So this test is selected under these specific requirements, which is the data needs to be normally distributed. It needs to be interval or ratio level data. Okay, the research design needs to be an independent measures design, and like I said, the sample needs to be larger than 30 participants, or it can be dependent on. You can choose this depending on whether your data was found to be normally distributed or not. Okay, so Mann-Whitney U is the counterpart of independent samples t-test, and it has similar requirements. Okay, and here you need to have data that is not normally distributed, okay, and it's ordinal in data. And the Mann-Whitney U test does convert it from interval and ratio to ordinal data, and it has to be an independent measures design. So these two are for independent measures design. For repeated measures design, the paired samples t-test is a parametric test, okay, and you can use it under the conditions of being normally distributed, having interval or ratio level data, a repeated measures design, and sample size, again, I'm not going to repeat that. And Wilcoxon signed rank test is the counterpart of the paired sample t-test. It is a norm-parametric test, and you can use it when it is a repeated measures design and the data is not normally distributed, has ordinal data, and yeah. So these are the 4 tests that you can choose for your IA. So since this data was found to be normally distributed, and as you can see, it's a pre-test and post-test of depression scores from the same individual, which means it's a repeated measures, I would choose a paired sample t-test, okay? And my recommendation for this calculation is socialsciencestatistics.com. You can just Google that and you will find it. And if you go under calculators, there's a whole list of different statistical analysis that you can select from. Okay, and since I'm using a repeated samples t-test, I can click on t-test calculator for 2 dependent means. Okay, and click on that, and this is what it would look like. But the other test that would be relevant is this t-test calculator for 2 independent means, which is the independent sample t-test. Then there's the Mann-Whitney U test, which is the counterpart of the independent samples t-test, and the Wilcoxon signed rank test calculator, which is the counterpart for the dependent sample t-test. Okay, so I'm just going to go over the t-test calculator for 2 dependent means, and the procedure would be pretty much the same for the others. Okay, so this is what the first page would look like, and they provide you the requirements as well. You can use these points when writing your IA and why you chose that particular test. Okay, so then you click on Take Me to Calculator. And again, as easy as the normality test was, this is the same. So treatment 1 and treatment 2. So under treatment 1, I can use my pre-test scores and copy and paste it over there. And then treatment 2 will be my post-test scores. And you can choose the significance value. Like I said, 0.05 is the recommended one. And my hypotheses would be that depression scores reduce in the post-test score. So that's a one-tailed hypothesis, okay? So you need to select whether it's one-tailed or two-tailed. And once you've chosen that, you can click on calculate, and this is what it's going to look like. Okay, these are things that you don't really need to focus on, but I would recommend that you take a screenshot of this page, okay, and include that in your appendices. But what we want to look at is the p-value is 0.00001. Okay, so at a level of 0.05, the p-value is much smaller than 0.05, which means that we reject the null hypotheses that there is no difference, okay, and accept the research hypotheses, which is what we saw from the mean also. And now we have statistical analysis and inferential statistical analysis tests that are confirming the same. So it's as easy as that. This does not require you to do several different steps like you would have to do on Excel. So if you don't have access to SPSS, you can use socialsciencestatistics.com, and make sure that you take a screenshot of this whole page, okay, and include that in your appendices. So once you have conducted the inferential statistics and also have your descriptive statistics in place, it's about how you report it in your analysis section. I would recommend limiting this section to about 300 to 350 words at the most. I would first present the table and the graph, okay, followed by 3 paragraphs. The first paragraph being the results of whether your test is not normally distributed or not, okay, followed by paragraph 2, which will explain your choice of descriptive statistics and also describe the results in terms of if it's mean and standard deviation, what is it that it's showing, and transition into the choice of inferential statistics in the third paragraph, along with what those mean in terms of your hypotheses and also a link to your original theory or model. Okay, I'm going to share and show you what one could do for this section. Like I said, I would start with the table and the graph, and these are the 3 paragraphs that I have. So in the first paragraph, so to test whether the data was normally distributed, a Shapiro-Wilk test for normality was utilized, which is known to be the most powerful test for normality. So you are explaining why even Shapiro-Wilk was chosen, okay? This isn't necessary, but it could just add to your report. Since the p-value for both conditions was greater than 0.05, we accept the null hypothesis that there is no statistically significant difference between the distribution of this research's data and normal distribution. Okay, so in the first paragraph itself, I'm addressing normality. And that way I can use the fact that my data is either normally distributed or not in explaining my choice of descriptive statistics and inferential statistics. So in the second paragraph, I would start by explaining my choice of descriptive statistics. In this case, it was mean and standard deviation. Here, then I will mention table 1 and table 2 presenting the descriptive statistics, and I would give them a brief description of what it is and what it's suggesting. And then you go into a little more on that decision. You mentioned which test you have chosen and on what basis. Okay, so I've mentioned it was parametric, and because it was normally distributed, it had a ratio level data, the experimental design, and that the two conditions were paired with one another. Okay, so I have explained my choice of paired sample t-test, and then you describe the values that you got and how that links to your hypotheses, and you can link it back to your theory and model as well. So based on the results, it can be concluded that therapy as an intervention can have positive effects on depression. Okay, and here you can link it back to the dual processing memory. This is just an example, so you can link it back to reconstruction of memory, whichever experiment that you have conducted and the original research. Try having at least one line linking it back to the theory, okay, which you will do again in your evaluation section, but regardless, this would help you give a thorough conclusion on what the results are indicating and showing. So I hope you found this video helpful. The analysis section is pretty straightforward if you follow the steps that I've mentioned. It is important, again, to reiterate that you need to include the calculations and your raw data in your appendices and not ignore that, because you can lose 3 to 4 points just for having missed that step. And choosing the appropriate test is also important, and ensuring that you link it back to your hypotheses and also theory.